a life of complete success, happiness, and fulfillment, you must find your purpose. You see, if you don't know what your purpose is, if you don't know what drives you, what inspires you, then you have no reason to improve your life. How can you improve your life if you have no reason to improve it? Why do you do what you do? Why do you do what you do? What's the reason? Why do you exist? Do you know what it takes to be great? Are you willing to go the extra mile? I tell you time and time again, you will get tired. But if you have a why, it will give you that extra strength, that extra foot you need, that extra hour you need, the courage. Why are you different from everyone else who's trying to do the same thing you're doing? What makes you stand out? Why are you so important? Find your why. Your why will pull you up when you feel like you don't have the strength to get up anymore. Your why will keep you fighting when everyone else thinks you are out for the count. Why? Who are you fighting for? What drives you? Is your purpose your family? Is it to prove the doubt is wrong? Is it to prove yourself right? What is your purpose? Write down your purpose. Carry it with you everywhere. Feel it deep and promise yourself every day you will live your purpose with zero excuses. Somebody's waiting for you to mess up. Somebody's waiting for you to give up. Someone is waiting for you to fall. So when you're challenged by life, what are you going to do? When you feel like you're at your lowest point in life, will you throw in the towel? Or will you make the move to be successful? Don't look back. Just remember where you came from. And let that drive push you to go forward. It's not always going to be an easy road. And when you reach success, you won't take it for granted. You cherish those moments you had to go through. Those moments you were without. And when you fall down, get back up. Dust yourself off. You need to find something that drives you. Something that no matter what happens, this part of you does not change. This drive in you does not change. This purpose never dies. No matter how many times life knocks you down, your purpose pulls you up every time. This is the reason I will fight for my dreams. This is the reason I will not take no for an answer. When it hurts, keep going. Those cloudy days, those storms, telling you to keep going. Those times in your life where you can't see how you're going to make it. Some things you can't change. You just have to live with it. But if you do have a choice, make the right choice. Your purpose is that one thing that lights you up. It's the one thing that will get you up early. That one thing. When you're doing it, time stops. Your purpose may be something you don't want. It may be seeing someone in your past and thinking, no matter what, I will ensure I never end up like that. Your purpose is always something that lights a fire in you. I will do this no matter what. My family is counting on me. My friends are counting on me. I am counting on me.
Well, on that note, I want to welcome you guys all to Mathematics Demystified. And our vision is to make mathematics every student's delight. These are our contact details. You are free to join us on social media, Facebook. You can visit our YouTube channel for past videos. And you can also follow us on Instagram. So on that note, I want to say a big thank you for those of you who are able to make it to today's class. And as I've said, today, we are going to be starting dealing with the theory of logarithms. We've done indices, so we have starting with logarithms today, theory of logarithms. So I just have a little explanation of what logarithm is, and then also the interplay between logarithms and indices. All right, I said the logarithm of a number A to base B is the index of B in A. What are we saying here? What we're saying is that if you have a number A and it has a base, you have a number and it has a base, the logarithm of that number is what is the power to which you will raise B that will give you A. What is the power to which you will raise B to give you A? So that number will be the logarithm of A. So mathematically, if log A to base B is equal to P, if log A to base B is equal to P, then B raised to power P is equal to A. If you look at these two equations, the first part of it, which is log A base B equal to P, is logarithm part. Then the second part, which says B raised to power P is equal to A, is indices part. You can see the interplay. That's the interplay between logarithm and indices. And in the course of us dealing with logarithms, we will have a lot of reference to our knowledge on indices. And that is why in most cases, before you go into the subject of logarithms, you must have been well grounded in indices. So the above shows the relationship between logarithm and indices. So I said, while, as I've just mentioned, log A base B is equal to P is the logarithmic form, then B raised to power P equal to A is the index form. I also want to remind you guys, I hope for those of you who have attended our class on indices, I said indices is plural, index is singular. So let's quickly move on to the laws of indices. We are going to examine 5 laws of indices. These laws are the foundation, they are the basic structures. If you get this law correctly, I can bet you will be able to trash any problems on logarithm. So the first law, this first law of indices is usually referred to as the multiplication law or addition law, whichever way you want to look at it, multiplication law or addition law. And what does it say? If you have two numbers, let's assume you have A and B. So they are saying that the logarithm of A multiplied by B is equal to the logarithm of A plus the logarithm of B. Let me come again. If you have two numbers A and B, the first law is saying that log A times B. Please note, I did not say log A times log B. Log A times B is equal to log A plus log B, provided, there's a proviso, provided the two of them are in the same base. They have the same base. So what we're saying is the logarithm of the product of two numbers is equal to the sum of the logarithms of the two numbers to the same base. The logarithm of the product of two numbers is equal to the sum of the logarithms of the two numbers to the same base. Please, I need to re-emphasize that word, the same base. So mathematically, we are saying that log P times Q, log PQ base B is the same thing as log P base B plus log Q base B. Then you can interchange them. You can turn them the other way around. You can say log P base B plus log Q base B is equal to log PQ base B. So that's the first law of indices. So for illustration purpose, now we're saying that, for instance, if you have log 2 times 10 to base 10, log 2 times 5 to base 10 is the same thing as log 2 base 10 plus log 5 base 10. So invariably, you can also say that log 10 is equal to log 2 plus log 5 because 10 is equal to 2 times 5. I hope we are getting the interplay. Once you are able to understand these fundamental basics, I can assure you there is no problem you won't be able to trash on indices. Oh, sorry, on logarithms. Also, log 5 times 4. Log 5 times 4 to base 10 is the same thing as log 5 to base 10 plus log 4 to base 10. So what we are saying in essence is that log 20 to base 10 can be written as log 5 to base 10 plus log 4 to base 10. Then the same way, log 6 times 5 is equal to log 6 plus log 5. I said note, I think I've emphasized this. For this rule to hold, the bases must be the same. They must have the same base. And I also have here that note that log P base B multiplied by log Q base B is not equal to log P base B plus log Q base B. Please, this last statement is very important. This last expression is very important so that we don't begin to mix them up. A lot of students almost always get it wrong with this. So that's the first law of logarithm and its illustration. The second law of logarithm, which is referred to as the division law or the subtraction law, says that if you have two numbers and you are dividing the numbers, so the logarithm of the division of two numbers is equal to the subtraction of the logarithms of the two numbers individually. Let me reframe that. If you have two numbers A and B, we are saying that log A divided by B is equal to log A minus log B. Just in the same way, which is very similar to the multiplication or the addition law, the logarithm of the division of two numbers is equal to the difference of the logarithms of the two numbers to the same base. To the same base. I need to also emphasize that. So what we are saying is that if you have two numbers, P and Q, so we are saying log P divided by Q to base B is equal to log P base B minus log Q base B. Or you can turn them, you can interchange them. Log P base B minus log B, log Q base B is equal to log P divided by Q to base B. Now, let me state something clear here. There are times that you will be given a problem in this expression in the form of log P over Q. And in trying to solve it, you may need to change it to the form log P minus log Q. Or there are times you may be given a problem in this form of log P minus log Q, and you may be required all you just need is to change it to the form of log P over Q. Please, let's put that at the back of our mind. And the same thing also happened to the product or the addition law. So for illustration, we're saying that if you have numbers 3 and 2, so log 3 divided by 2 to base 10 is equal to log 3 to base 10 minus log 2 to base 10. In the same way, log 7 over 4 to base 10 is equal to log 7 to base 10 minus log 4 to base 10. Then I also stated that you need to also be sure that all the numbers are in the same basis. The basis must be uniform for this rule to apply. In the same way, log P divided by log Q is not the same thing as log P minus log Q. Log P to base B is not the same log P to base B divided by log Q to base B is not equal to log P base B minus log Q base B. Just the same thing I emphasized while we were treating the addition law. So please, you will need to put these at the back of our minds so that we don't get them mixed up. The third law states that if you have log P raised to power n to base B is the same thing as n log P base B. That means if you have a logarithm of a number in index form, you can just pick the index and multiply it with the logarithm of that number. So we have log P to base B raised to power n. So we have log P raised to power n. So we're saying that it's the same thing as n multiplied by log P to base B. Let's look at some illustration. For instance, if you have log 2 raised to power 3 to base 2, log 2 raised to power 3 to base 2 is the same thing as 3 multiplied by log 2 to base 2. I hope that is clear. The same way, let's look at this. We have log 125 to base 5. Log 125 to base 5. Now, 125 can be expressed as 5 raised to power 3. So in the same way, this log 125 base 5 is the same thing as log 5 raised to power 3 to base 5. And applying this third law of indices, it will give us 3 multiplied by log 5 base 5. These are some of the things you will need to put at the back of your mind when you approach any problem on logarithms. The fourth law states that log B to base B is equal to 1. The log of any number and to the same base as the number is equal to 1. So what we are saying is that if you have log 10 to base 10 is 1, log 100 to base 100 is 1, log 1 million to base 1 million is 1. So logarithm of any number to the same base is equal to 1. So we're saying log 3 to base 3 is 1. Now, if we go back to these illustrations we have for the third law, for instance, you have this one as 3 log 5. So what he's saying is that, what this fourth law is saying is that instead of writing it as 3 log 5 to base 5, we can rewrite this log 5 to base 5 as 1, so that we will have 3 times 1, which will be equal to 3. So invariably, log 125 to base 5 is equal to 3. I have the illustration here. Log 125 to base 5 is the same thing as log 5 raised to power 3 to base 5, which is the same thing as 3 log 5 base 5. And from the fourth law, we know that log 5 base 5 is equal to 1. So this becomes 3 times 1, which is equal to 3. Then the final law, the fifth law of indices, is saying that the logarithm of 1, log 1 to any base, log 1 to any base is equal to 0. Log 1 to any base is equal to 0. If you want to prove this, you can just pick your calculator and press log 1. It will give you 0. So those are the basic laws of indices. And as I've said, if you acquaint yourself with this law very well, you won't have any problem treating any mathematical problems on logarithms. So I want us to look at some exercises. Before, at least to buttress all what we have been saying. So the first one says, it is general law for every problems we are going to be solving. And when your examiner gives you any question, when you have any question, you may be told that you may have this proviso, unless otherwise stated, assume that all the logarithms are to base 10. But if they will not be to base 10, it's either they will be indicated or it will be stated. So the first problem we have is saying we should evaluate 3 log 2. We should evaluate 3 log 2 plus log 20 minus log 1 point. Please, if you can't hear me, you may need to check your internet. You may need to check your connection. So the question says, evaluate without using tables. 3 log 2 plus log 20 minus log 1.6. Please, if you can't hear me, you may need to check your internet. If you can't hear me, you may need to check your internet. All right. So the first thing that should come to our mind is, okay, what are the laws? We'll write down the laws. So I will advise that anytime you have any problem to solve on logarithms, you can just scribble the laws, put it by your side, so that you can now begin to look at, okay, which law do you think will be applicable? Now, if we look at this exercise, this is we have addition and subtraction. So the first thing that should come to your mind is the law that has to do with addition and the law that has to do with subtraction. The law that has to do with addition and the law that has to do with subtraction. So these can be rewritten. We can rewrite these as, this 3 log 2. We can rewrite it is the same thing as log 2 raised to power 3. You'll see that we have applied one of our laws there. If you look at it, I think it's either the third or the fourth law. The third law, we have applied the third law to change the form of 3 log 2 to log 2 raised to power 3. So if we continue, log 2 raised to power 3 is the same thing as log 8. So we have log 8 plus log 20 minus log 1.6. Now, we can now apply our multiplication law and our division law so that this expression will now become log 8 times 20. That's the 8 times 20 because of the addition sign, then divided by 1.6 because of this negative sign. So we'll have log 8 times 20 over 1.6. which will give us log 160 over 1.6. If you divide 160 by 1.6, you have 100. So the whole of this expression is the same thing as log 100. Now we can simplify this further because we know that we are working with base 10. We can simplify it further to say that log 100 to base 10 is equal to log 10 raised to power 2 to base 10, which will be log 10, 2 log 10 base 10. And we know that log 10 base 10 is 1. So that we have 2 multiplied by 1 equal to 2. Now we can see that from this little exercise, we've been able to combine the 4 laws. We have been able to combine 4 laws of indices, sorry, 4 laws of logarithms to solve this. So I also want to reiterate the fact that there is no question, there may be no question that it will only be one law that will apply. And there may probably be no question. There may probably be no question that will, we only require one law. So it will be a combination of all the laws. The next question. Now, we were told that the second question says, given that log 2 is equal to 0.3010, log 3 is equal to 0.4771, and log 7 is equal to 0.8451. We are asked to evaluate the following. The first of them is log 5. We are asked to evaluate what will log 5 be. Now, the first thing that should come to your mind is, how can you transform 5? How can you manipulate 5 to give you numbers that will be relating to either log 2, log 3, or log 7? Now, if we look at log 5 as a number, some people may say log 5 is equal to log 3 plus log 2. No. Log 5 as a number is not equal to log 3 plus log 2. But we can say, since we are working with base 10, we can say 5 is equal to 10 divided by 2. We can say 5 is equal to 10 divided by 2, so that our division law will come into place. So that log 5 will be equal to log 10 divided by 2, which will give us log 10 minus log 2. Now, since we are working with base 10, log 10 base 10 will be equal to 1. Then we have our log 2, which we are given to be 0.3010. So this will be 1 minus 0.3010, which will give us 0.6990. I hope that makes sense to us. Then the second one says log 35. Now, in the same way, we will try to express 35. We'll try to express 35 as multiples of 3, 2, and 7. 35 is 5 times 7. Then we know that we can also express 5 as 10 divided by 2. So we can have 35 to be log 5 multiplied by 7. Please note, I didn't say log 5 multiplied by log 7. So log 5 multiplied by 7 is equal to log 5 plus log 7. And borrowing the clue we used for the first example, our log 5 will be equal to log 10 minus log 2. So that our answer will now be log 10 minus log 2 plus log 7, which will give us 1 minus 0.3010 plus 0.8451. 1.5451, and it will give us 1.5441. Now, I will want us to do a little exercise here. You will do a little confirmation here. Since we are working with base 10, you can quickly, maybe after the session, you can quickly take your calculator and press what log 35 will give you or what log 5 will give you. Now, let me go over that log 35 again. We said 35 as a number is a product of 5 and 7. 5 times 7 will give us 35. Now, so 5 times 7 will give us 35, so that we can have our log 35 will be log 5 plus log 7. Log 35 is log 5 plus log 7. Now, if you look at the first example we did, we got log 5. We got log 5 to be log 10 minus log 2. So instead of writing log 5, we just put log 10 minus log 2, which is this, log 10 minus log 2, then plus log 7. Then log 10 is 1, log 2 is 0.3010, then log 7 is 0.8451. So if we do that, we'll get 1.5441. So the last example we are going to consider is log 42. We are going to consider log 42. Log 42 is the same thing as 6 times 7. So we can simply say that log 42 is the same thing as log 6 times 7. But we can further break down 6 to 3 times 2, so that our log 42 will be log 2 times 3 times 7. So, which will give us log 2 plus log 3 plus log 7. So log 42 will be log 2 plus log 3 plus log 7. If you multiply 2 by 3 by 7, you will get 42. So that will give us 0.3010 log 2 plus 0.4771, that's log 3, plus 0.8451, which is log 7. So addition of these three will give us 1.6232. 1.6232.